Hello, good morning. My name is Fatima, and today's workshop is about using speech recognition software on a Raspberry Pi device to communicate and send messages to another Raspberry Pi device using MQTT. Today's workshop's outcomes are learning how to connect devices to the Raspberry Pi, mainly the LEDs, buzzer, and the USB camera. We also learn how to enable speech recognition in Python on the Raspberry Pi, and also using the speech to control the devices that are connected to the Raspberry Pi. And lastly, we'll be learning how to use MQTT, which is a messaging communication protocol, and we'll learn how to publish messages from one Raspberry Pi, which is going to be connected to which will be used for the speech, and the other Raspberry Pi is a client which will be receiving the messages from the first Raspberry Pi. And the tools are mainly required. You need two Raspberry Pis. You can get a Raspberry Pi 3 or 2. Those also work. You need to have paho.mqtt installed beforehand. But also I will show you how to install them. So starting with the workshop. What is the workshop all about? We need a voice recognition based on a Raspberry Pi, which will recognize whatever text you're speaking, in English mainly, and will be converting them into messages or trying to decipher what the message means. And our messages will only relate to, for example, switching on or controlling an LED, switching on a buzzer, or capturing an image from a camera. And those commands are going to be used to be sent via MQTT and will be based on will be written in string format, and once they've been sent or published to the other Raspberry Pi, we'll be using those messages to control them, like turning on and off and so on. So the workshop is divided into 3 parts. The first is installing the speech recognition and also configuring the microphone to the Raspberry Pi. And the second is to add the devices to the other Raspberry Pi, which are mainly the LEDs, the buzzer, and the USB camera. And lastly, I'll be showing you how to work with the MQTT protocol step by step. So first step is connecting the devices to the Raspberry Pi, which I will be showing on later on, but this is the pin diagram. If you would like to note down anything specific, such as the pin numbers, but I will be going through them slowly. So all of these LEDs and the buzzer and the USB camera, which is connected to the Raspberry Pi. Okay, so let's start with MQTT, the basics. The concepts you need to know for this workshop are what a publisher is, what a subscriber is, what does client and a broker mean, and what functions you would need to work with for the workshop. Starting with the basics. So what does MQTT stand for? MQTT stands for Messaging Queuing Telemetry Transport, and I'll start with an example of showing how it works, because if you're familiar with client-server architecture, this will be easy to remember. So this is an MQTT broker. For now, you just need to remember that there is always one broker and there are going to be many clients that are with the broker. So this is a publisher, and the publisher is a connected sensor device, and it will be recording speed. So whatever like speed measuring device you're using, that will be connected as a publisher. And the subscriber, which is a mobile device, and a backend, which is also a subscriber, it'll be receiving those published messages, but it'll be receiving it from the broker, not directly from the publisher. So these terms might sound confusing for now, but it will all make sense in just a bit. So what are the advantages of using MQTT? We're using MQTT because it's more lightweight and it has lesser packet overhead than HTTP, and it's very simple to use and very easy to understand. So as you must have noticed, there is a publisher and a subscriber. So publish subscribe pattern is based on having different clients that are one type or the other. So they can be publisher or a subscriber, and they could be publisher and a subscriber. And what it means is they're all communicating. Only the publisher is going to be sending a message, and the subscriber is the only one receiving it. and if it is based and only receiving it if it's subscribed to a topic. So that's hence the name subscriber. It's very similar to how you're subscribed to YouTube channel and you get videos based on that channel if you're subscribed to it. And the connection between them is the broker. So the third component, which we'll look into a bit right now. So the client, as I mentioned earlier, does include the publisher and subscriber, and the broker is the one that filters and receives the messages, and it sends it to the clients. And this is done through a topic-based filtering. What is a topic? Right? So a topic, I'll explain through an example. So for instance, you have a home where you have many rooms and you want to, for example, control like lights, or you want to control the AC or the temperature, and but you have many different rooms, right? So each different room, for example, a living room, the bedroom, or the kitchen, all of those lights will be the topics because they're all different and they all have their individual components, or the sensors, right? And the each of the topics, they don't like they might, or they like each of the clients, the clients, they may either need one topic, or they may need to be subscribed to all of them if they are a subscriber. And they only receive the message if they are subscribed to that particular topic. And moving on, this is the code. I'll go through it step by step, starting with the publisher code. So there are many different versions of MQTT. You're probably using it in a mobile app, you're probably using it in a microcontroller, or it's a program running on your laptop. So they have different versions of it, but the main thing you need to know is that you use a publish function. And the format of it varies from device to device, but based on this code we're using from the Raspberry Pi, publish is just an alias. It's not an object that I'm using. It'll be explained like in more detail later on, but we're using the single function, and this is used to publish a message, and we always need to publish based on topics. So like I mentioned earlier, everything is organized in topics, and the topic in this case, it's light/green light, right? And then the second variable, as you can see, is off. So what are each of these? The first is a topic, and the second one is the message that you're sending, or the payload, not the message. So the format goes topic, payload, and this is the host name. So this is just how the format is, and make sure they are in quotations because they are string values. And moving on to the other type, which is subscriber. So this is a part of the code that we'll be using today. So starting with the first function, which is onConnect, it's already provided the passing like variables. So starting with how do you use them. So once you're connected to MQTT, you need to make sure that your connection after you have a successful connection, it'll try to reconnect and make sure that the subscriptions are renewed. So initially your subscriptions need to have whatever topics that your client is subscribed to. For instance, I've written here is light/green light, light/white light, a sound, which is a buzzer, and a vision. Like I've written them based on the devices that I'm using. So camera, buzzer, white light. So make sure you use this format, and client is just an alias, and subscribe is the function you're using. All you need to pass is the topic name. So it could be anything, but make sure you're remembering those specific topics once you're going to be publishing. So the second function, which is the on message, the first thing you see here is the printing of the message and the payload. So this is to just make sure for debugging, like whether it has successfully connected and whether it has received from the publisher or from the broker specifically, like the message. Here you can see client is actually an object. So this is the object MQTT. And this is the client which we're going to change it to. So make sure that you pass the onConnect, which we just looked at. OnConnect is going to subscribe once it has connected to the broker. And the messaging protocol will actually just print the message that you're using for this example specifically. And don't forget to connect it to this host name and through this port and this address. So and also the last thing is to always make sure it loops forever, so that once you have the once you have the broker or the client running, you want to make sure that it keeps on receiving messages as it goes on. And these are the references, and now we'll show how the code works. Okay, so now that the Raspberry Pi has been connected, you need a microphone enabled or microphone connected via Bluetooth or USB, whichever microphone you're using, and connected to your Raspberry Pi. And this will be used for the speech or the voice commands and be used as an input. So the libraries that we need to install for speech recognition to work, you need the speech recognition library. I already have them installed, so this is the command for speech recognition. You also need to install Pi Audio and Port Audio. So those are already present in this machine. So you can install pip install Pi Audio or by writing pip3. And you also need to install Port Audio. I already have that installed in my downloads, and just to save time, I'm just showing you how that works. So the next thing that you need is a device ID. So let's start by showing the code here. Okay, I have written this file to get the index of the microphone that I'm using. So I'll explain it step by step. I've imported the library Pi Audio, and I'm using it to get the Pi Audio instance from that library. And to get the information, I need to use this function, which is the Pi audio function. It's including the library. Is to get the it needs to get the host API information. And lastly, you need to get the number of devices. So this is all related to the Raspberry Pi, right? Okay, so what this code does, it retrieves all of the number of devices. From them, it gets the information by its channel, and it prints out all the information. So there's a device ID, and it gets it from the host information we got earlier, and then it gets the name for it. So when I run this code on my terminal, let me just make those changes. Python 3 get index. What it shows me is these two last lines. It shows input device ID 6 and input device ID 10. So you don't really get much information from this, but what we will do is I'll run the code and it will show that it will be recognizing based on the index. So you need this device ID or note them down, 6 and 10, and test whether 6 is the right microphone or 10 is the right microphone. The reason why there might be more of these devices is probably because you have you have devices connected via USB. So next step is to write the speech recognition code. So I have all of the things set up. If you do need to test whether your audio is working, there are other methods to do so, but please do check them out before you start writing the code. So I am going to write this new code text, right? And I'm going to open it in the editor. So I'll just open it here. Open it by the IDE so it's much easier to understand. Okay, so first things first, you need to get the speech recognition object. So everything has been installed. You need to import the speech recognition library, and I've installed it. So now you need to get the instance of this object and need to store it as you need to get the recognizer object from the library, and next you need to create an object for speech, and this is obtaining it from your microphone. So it will get it needs to get the input and register that device as being used as a microphone for this specific scenario. So get index, and you need to, sorry, device index. You need to specify the device index you're using. So for mine, I'm using 6. Next is you need to use this speech or this object as the source. So this is your input device, and you need to, once it has connected, you need to make sure that it prints something to like to test. We would have to write something like say something. So then the person would start or would know that the microphone has initiated recording. So the next object we need is the audio, and what audio is, we need to make sure that we are listening from the source. Actually, before that, we need to make sure that we adjust for ambient noise in case there is any from the source, and as we said earlier, the source is used as speech. So yeah, and then you need to also have the um, you need to also make sure you have the threshold, which is r dot pause threshold as 1. Um, there isn't a specific reason, but it's part of the code to retrieve the speech clearly. So I need to set the object to listen from the source, and next we need to write code to recognize the object, or at least print out what it has recognized. So I'm going to write a try catch statement. In that, I'm just going to specify as a debugging statement that it is recognizing or recognizing. And now we need to make sure that the object that we were using earlier, which is R, is recognition. Yeah, so R is being used to sorry, R is being used from the Google recognize.google function. So this is my function, and I need to store this object into recognize. So once it has been retrieved from this audio, and we want to specify the language. So this is another parameter we need to pass is the language, and you need to write it in this way and make sure you write English. So you can look up for different languages what you would need, what the specific variable would be. So now that you have retrieved the object and it's been recognized, it's being stored in this variable. Now you just need to print out what the object said. So I'm going to say you said recognized, and we've gotten the object. Now, so now that this code is working, would be working for sure. We just need to make sure that any exceptions will be caught. So this is in the case of there wasn't any value retrieved or there wasn't any input. You just need to have these specific statements written. So I'll just mention for unknown value in case that is the exception caught, and then need to print Google speech recognition could not understand audio. Right, and the other The other exception that we need to make sure it doesn't happen is if it wasn't able to obtain any results for that audio. So I'm going to say request error as e, this is an alias, and you just need to print this is the error here. Google speech recognition. Okay, and lastly you just need to mention the servers that needs to run, and as well as the format, and just mention that the format you're using is of e, the exception that you've got. So this is, yeah, okay. So now this is clear and we've completed the code for speech recognition, right? Now what we need to do is make sure that it works. So try to save the code before you run it from the terminal. I'll actually just use the IDE to show you that it works. Just a second, there's something missing here. Right, okay, so now that that's fixed, we just need to make sure speech recognition service, okay, yeah, I think that would fix it, and the code is running. Okay, so it says say something, and I'm talking through my microphone as well. So in a minute it'll show that it has recognized something from my audio. Yeah, so this is not exactly what I said, but it's close to what it understood from my audio. So now that we've cleared out the speech recognition part, we need to start focusing on MQTT. So this code is to publish the messages to the broker or the client that we are also connected to, the other Raspberry Pi. So now we need to just complete the code, right? So what is missing from here is you need to write the logic of the code exactly after you've retrieved the text. So the commands that we're using are going to be like based on what you said, it needs to do something or it needs to send a message. So I also need to import the Baho MQTT code as published. Okay, so this is a publisher, so it needs to be written in this specific way. Okay, so now we just need to write the commands that we'll be using. So before we get started here, I will mention that the specific commands that I am going to write, just to avoid repeating the same text over again, I'm just going to write or mention that the text, the commands or the words that I'm using for the commands are written beforehand. So there's on and then there's off, right? There's also command to take a picture. So just mention command for picture. Okay. And then you need to mention the object. So I'm going to mention the lights. Just mention that as the white light, since those are the ones I'm using. And a buzzer. Okay. So we have all of the needed commands, and now we just need to write an if-else statement, which is going to be simple, and I'm going to show you how that works. Okay, So we need to look for certain messages or certain words in your commands. So I'm going to say if you said on or if you said off, just to see which device. So it needs to say whether it was the white light, the green light, or a buzzer. So I'm just going to say if light 1 was in your command or your what recognized, and what I'm going to do with it is I need to publish this message. So if you remember earlier from the presentation, I said you'll be using an object and the function would be single, and you just need to pass three parameters. The first would be the topic. So here I'm going to name this my white light, and this is my topic, and I need to send a message. So this actually this should be after, but I'll just explain. So this is going to be publishing a message that it is to the white light, and the second parameter is going to be the message, which I'm going to leave empty for now, and then you need the last parameter, which is the host name, and this is test.mosquito and .org. So that's the whole command. Okay, so as well as the device, you need to remember like whether it's on and off. So you also need to check whether the command on was mentioned in your message. So I'm going to say if command on, publish this message. So I don't have to repeat that or have multiple if statements. I'm just going to divide it in such a way. So the second command is command off if it is, and now what's the message you'll be sending? It will be sending a message saying turn the white light off. I'm going to make it simple and just say on because the topic is already specified as the device and the message is the only thing missing. So the same thing goes for your white light, but except you need to make sure it is going to be off. Okay, so I'm going to copy this code because it's going to repeat for the buzzer as well as for the second light that I'm using. Just, okay, light 2 and sound. So now the only thing that would change in all of these commands are the topics because all of them are going to have very similar ways of being on or off. So I'm going to say green light and copy this here and the buzzer. So this is my topic for the buzzer. Okay, so now we've gotten the camera, not the camera, but the lights and the buzzer. We need to also write a specific command for the camera. So first things first, I'm using the camera as a topic, and all I have to pass is on, because on my other client, which you'll see later on, it will only have a command for on and off for camera. It won't need to check whether the camera is on and off. So the only thing you need to specify here is if you've said camera, camera. So I would say this command, take a picture. So I only need to check for the camera, this command. Whether the camera word was, whether you said take a picture, then that means you mentioned this specific command. So I'm going to say camera is in this object. Just publish the message, which is that the camera is on. So this part of the code is complete. So this Raspberry Pi is successfully a publisher and it has registered and it also has all of the topics mentioned clearly. So for now, we'll be switching to the second Raspberry Pi, and I will show you this again and how to run the code from this Raspberry Pi. Okay, so this is the second Raspberry Pi, and it has already been set up, connected to two LEDs, a buzzer, and a USB web camera. So now we need to do is install the MQTT client on this Raspberry Pi. I already ran this command and I already have this installed on my Raspberry Pi. So use this command to clone the GitHub repository, and next thing to do is click on type Python 3 install from that directory. So the next step is to set up the camera. So run this command to enable or install the web camera, and you can also check whether your camera is actually enabled. So go to Raspberry Pi configuration, from your settings, check interfaces, and it should be enabled. Okay, so next what we're going to do is open a Python file. Okay. Okay. So now we're going to edit this file. So first things first, you need to import the paho.mqtt.client package. As you notice, like for the publisher, we had mqtt.publisher. So we're going to import it as MQTT, the object. And the next thing is to interface all of the connections that we made to this with the code. So we have rpi.gpio and then import it as gpio. And next you need to make sure that the settings, the warnings are set as false, and the mode is set to BCM. So you can have board mode or the BCM mode. I'm going to select the gpio.bcm, and you should do so as well, checking the bin diagram, which is also in the description of the video. Okay, so set up the first bin. So this is the white light. So I chose bin number 17, and I'm going to set it as the output. The same goes for the green light, and then the buzzer, which is bin number 23. Okay, so now there are two functions. When we mentioned in the slides earlier, we said there are two functions which are going to be used by the client when it is a subscriber. So there is onConnect, and then there is an onMessage. OnConnect will be called when the MQTT client has successfully connected. So this is where it's important to subscribe to the topics that it would require to use or would need to. So in my case, I'll subscribe to all of the components that were added to this Raspberry Pi. OnMessage will be when the publisher sends a message to the server. So this is when that function will be called if it's subscribed to this topic. So I'm just going to mention here client user data flags and RC. Okay, so here I mentioned that it has connected with result. So this is depending on the code. So the string, we need to take the result code from here and need to print it out to make sure that it is successfully connected. Okay, so next we need to subscribe to all of the topics. So all the topics from before, I remember, is green light, white light, the buzzer, and as well as the camera. So those are the exact topics you need to mention in the string, whereas they won't be connected properly. So green light, subscribe to the white light, and to the buzzard, and camera. Okay, so now on message. So this is the second function that we're going to complete. This is when the client has received all of the messages from that specific topic that it has subscribed to. So I'll just mention here the client, the user data, and message. So the message is the parameter that we are interested in. So just mention here what the message sent is, so it's easier to debug later on. I'm going to write message topic. Also make sure that use the conversion to string here, because the payload is not always string. So I'm just going to say payload string, and okay. So now the logic begins. So you've sent a message and you subscribe to topics. You need to check whether the sent message, whether its payload says on or off, and you also need to check the topic it's being sent to. So first things first, we're going to divide by the devices, and then we're going to check what the message says, right? So let's say if the topic message topic was equal to the green light, so whether it was the green light, this is the code for that, and then another for message topic, which is the white light. And the same goes for all of the other topics, just to check what the message says. Okay, so each of them just mentioned here if the payload. So what we're going to check in here is just if the keyword on is specified in this message payload. And if you're sure your payload is going to return exactly the value, then you don't need to mention if it's in, just say if it's equal to. Just mention here GPIO.output and the pin number and high. So just check. So here we said the green light is connected to pin number 6. Okay, so pin number 6 here. I'm just going to mention high, and then just need to mention if it's off. So like that, you follow for most of the devices, because they're mostly just output high or output low. So in this case, this is the output of low, right? Actually, this is GPIO dot high, and this is GPIO dot low. Okay, so the white light. Now I just have to check the same thing here. Right. This is very simple. You just need to output high or low every time you see an on or off. So the pin number for this is 17. Okay, so 17 is my first keyword, and then GPIO high. So I'm just going to move this. Okay, yeah. And on the other hand, if it's yeah, if it's off, if it says off in the message, then you have to make sure that it's off. Message GPO dot output, and just give it an output of low. Okay, so the buzzer is also the same thing, but with pin number 23. Okay, so this is very similar and easy. Okay, so for the camera, you also need to run a process. So for that, you need to import time and import OS. So import time, OS, and system. So sys. And then once you see that it says on, then you need to take a picture. So on means the camera will ask you to take a picture. So just type the statement, and if true, you need to mention here exactly OS dot system. So this is a system call, and mention here specifically the bash script. So there is a shell script running in the background which we'll edit on, but we need to just run this command to ensure that it will run successfully. So I'm going to write bash script.sh, and that's the only command that you need to do here. And overall, at the end, since you've finished this function, last thing is to create an instance of the client to make sure that it loops forever. So the client, you need to also pass the attach all of the functions that you've written right now, and you do that by calling this on connect. Just missed out here as well. Just make sure that you don't make any mistakes while doing this, because it's very straightforward and easy to do. The last step, or the second last step, is to call the connect function. So this connect function will connect to this host address, which is the test.mosquito.org. Yeah. Okay, so the last thing is to make sure that it loops forever, so whenever it disconnects, it'll have to reconnect automatically, which is the loop forever function. Okay. So just finish editing, and now we'll move on to the last step, which is running both the Raspberry Pis, and you'll see how it works overall. Okay, so the last and final step is to test out the code. I've opened the subscriber Raspberry Pi that we're using, and I'm going to run the code here first, and then I'm going to show how the speech recognition part works. So first, I'm going to enter here Python to run this code, and it's connected, as you can see. Now I'm going to switch to the second. Now I'm going to switch to the second monitor, and I'm going to run the code for the speech recognition. So I have my headphones down here for as a mic, and I'm going to say an example command to make sure it works. So turn on the green light. As you can see, now it says green light on. The next step is to just test out all of the steps. So I'm going to run the code here again, and lastly, I'm going to say take a picture. And as you can see here, it's taken a picture, but it says, oh, it didn't understand. Okay, so I have to run the code just one last time and to make sure that it understood. Take a picture. Okay, so now I'll show the other side, and it says it's capturing an image from the camera and it's writing it to a file. So the image right here, once it's done, I'll open it. Okay, so besides that, I'm going to show two other, just to show that all of the rest of the code are working. So the other devices are the buzzer and the other light, but I'm just going to show how the buzzer works. Turn on the buzzer. Thank you for watching this workshop. I hope you enjoyed and learned lots more. Please follow us on our social media and subscribe to our YouTube channel for more.